Don't let the name fool you. Our solar system's small bodies, asteroids, comets, and meteors, pack big surprises. Asteroids and comets, and the meteors that sometimes come from them, are leftovers from the formation of our solar system 6 billion years ago. While the planets and moons have changed over the millennia, many of these small chunks of ice, rock and metal have not. They are a lot like a fossil record of planetary evolution. At the very beginning of our solar system, before there was an Earth, Jupiter, or Pluto, a massive swirling cloud of dust and gas circled the young sun. The dust particles in this disk collided with each other and formed into larger bits of rock. This process continued until they reached the size of boulders. Eventually, this process of accretion formed the planets of our solar system. Billions of small space rocks never evolved. Amazingly, many of these mysterious worlds have been altered very little in the 6 billion years since they first formed. Their relatively pristine state makes the comets, asteroids and some meteors wonderful storytellers with much to share about what conditions were like in the early solar system. They might offer clues about where the water and raw materials that made life possible on Earth came from. NASA's robotic spacecraft allow us to visit comets, asteroids, and dwarf planets up close and even bring back samples to study. We are just beginning to figure out what these places are like, what they are made of, and how they formed. The amino acid glycine was discovered in the comet dust returned to Earth by the Stardust mission. Glycine is used by living organisms to make proteins. The discovery supports the theory that some of life's ingredients formed in space and were delivered to Earth long ago by meteorite and comet impacts. Like forensic detectives, scientists follow clues about what happened when the solar system was young to piece together the story of our origins. What we learn will also teach us about systems of planets around other stars and how life might develop there as well. We also explore small worlds to understand the hazards and resources in the solar system that will affect human expansion in space. These cosmic collisions are as natural as rain, although they happened a lot more often when the solar system was young. Scientists believe stray objects are fragments from earlier collisions slammed into Earth in the past, playing a major role in the evolution of our planet. With increasing regularity, scientists are discovering asteroids and comets with unusual orbits, ones that take them close to Earth and the Sun. Very few of these bodies are potential hazards to Earth, but the more we know and understand about them, the better prepared we will be to take appropriate measures if one is heading our way. Knowing the size, shape, mass, composition and structure of these objects will help determine the best way to divert a space rock found to be on an Earth-threatening path. Missions to comets and asteroids provide valuable information about their composition and structure, helping scientists assess the best methods to deal with those in potentially hazardous orbits. By immediately tracking potentially hazardous near-Earth objects, we have more time to study potentially threatening situations. NASA's Near-Earth Object Program was established in 1998 to coordinate NASA-sponsored efforts to detect, track and characterize potentially hazardous asteroids and comets that could approach the Earth.